Hello, welcome to another episode of GenServer. In today's episode, we're going to look on how we can start our GenServer process on demand using the DynamicSupervisor. All along, we've been using the GenServer start of RT tool to start our GenServer process. However, this function has its own con. So the GenServer starts a GenServer process and does not link to the parent processing, but now in case an error occurs within our message server, our GenServer process is going to be terminated. Let's see this in action. I'm going to start the interactive shell. Start the GenServer process using the GenServer start function. The GenServer start, it returns an OK, a tuple of an atom, OK, and a PID. Takes in two arguments. The first argument is the server module. In this case, this will be the message server. The second argument is a list of options. I'm passing it as an empty list. I've called it GenServer start with a capital S instead of a small. Okay, now we have been able to start our GenServer process. Let's check the process information. Call the process info. And pass it the PID. In this information, I'm interested with two fields, that is the links and the trap exit. Inside the links, you can see we are having an empty list. That means that our GenServer process is not linked to any process. The trap exit is false, and this means in case something goes wrong, the GenServer process is going to be terminated. Let's introduce that error within the message server. To do that, I had refactored the client module. Let me minimize this. So inside here, I've added another send message header. If it pattern matches the number 1, 2, 3, it's going to return to our system upgrade ongoing. This value is not handled, or rather, it's not expected within our message server. Inside here, the handle continue, we were calling the client send message. This client send message was we were either expecting a tuple of an atom OK with the status, or a tuple of an atom error. Then we were passing that value to the handle send message result. Handle send message result pattern matches the tuple of an atom OK and the status, or a tuple of an atom error and the status. Now we have introduced a new value, which we are not going to add another handle send message result for handling it. Therefore, our message server is going to raise an error. So let's introduce that error to see if our process will be alive or terminated. To trigger the sending of message, call GenServer casts, pass it the PID and the requests. The request is send message, and pass it the number 1, 2, 3. GenServer cast has returned an atom OK, so it always returns an atom OK even though it's going to raise an error. So you will always expect an atom OK to be returned by the GenServer cast. In here, you can see the process termination with reason, and this is the reason that we are having. So we are having a function clause error, which has caused our GenServer process to be terminated. Check if the process is alive. You confirm if the process is alive by calling the process alive function and pass it to the PID. You can see that the process was already terminated and we cannot do anything unless we restart the process again. By restarting the processes by calling the GenServer start function. Another function that we can use to start the GenServer process is the GenServer start link of RT2. The difference between the start link and the start function is that the start link starts the GenServer process and links it to the parent process. Let's call the GenServer start link. The return value of the start link is similar to that of the start function, and also the arguments is similar to that of the start function. A similar case of what I did before. We have started another GenServer process using the start link. Again, let's check the process information. In the links, you can see that we have a PID inside the list. This PID is the PID of the parent process. To verify that, call self within the interactive shell. And you can check that this PID, the PID here matches the PID inside the links field. The trap exit is false. Let's follow the same procedure we did at first. Let's send a request to a GenServer process because with the same phone number that will raise an error. Call the GenServer cast. Similar error to that, process termination with reason. So we are also having a function clause error again, and you can see the GenServer process with the PID has terminated. Also, on top of that, we are told that we are having an exit from the shell process. The shell process has exited with the reason an exception was raised. So the shell process has also exited due to the function clause error raised by our message server. Also here you can see you can see that another interactive shell has been started. If you call self, the PID that we are having now is different from what we had earlier. With the startlink function, the error that has occurred within the message server that has caused the GenServer process to be terminated has also propagated through the parent process, also causing it to terminate. The best way for us to start the GenServer process is under a supervisor. This is because the supervisor is configured in a way that it's able to restart the GenServer process whenever something goes wrong within the process. And also, since we want to start the GenServer process on demand, we can take advantage of the DynamicSupervisor, which will help us start the GenServer process under a supervisor. To use the DynamicSupervisor, first you need to pass it to the supervision tree defined in the application.ex file. In the application file, we have a function, the start function of RT2 defined. This start function is going to invoke the supervisor.start link, which is responsible for starting the supervisor with the given children. So the children here are the ones that are passed under this children variable. This is a list of all the children that you want to start under a supervisor. Also, we have the options that is passed for the sender supervisor. So here you can see we have the strategy 141, and also the supervisor is registered with the name the sender supervisor. Now what we want to do is to be able to start the dynamic supervisor under the sender supervisor. So that means it will be added as a child of the sender supervisor. Add it inside the children list. So we are going to define the dynamic supervisor. Register it with a name. So I'm going to pass it a name that we can easily identify it. So I'll name it the message server dynamic supervisor. Also, I'll pass it a strategy similar to that of the sender supervisor. That is 141. We have added the dynamic supervisor, which will be a child of the sender supervisor. Let's start our application and see how the dynamic supervisor is linked to the sender supervisor. Start the application by running the ex-smix command. Let's check the functions that we have under the process. So in the process, we can see process where is. Let's use the process where is. What it does is returns the PID or the port identifier registered under the name, or nil if the name is not registered. We can get the PID of the sender supervisor. So we have our sender supervisor. So this is the PID of the sender supervisor. Let me just pass it the variable. Then let's check the information of this PID using the process info. The registered name is the sender supervisor, which is correct. Then we have it is linked to 3 processes. I can still identify which process is which. Let's see if I call self, if the caller process will be among the process that is linked to it. No, it's not linked to the caller process. We'll just identify the others. Then it is configured to a trap exit. So with the trap exit, a trap exit is one of the best ways to isolate crash within linked process. So if the supervisor is configured to a trap exit, it will acknowledge that it has received an exit message from another linked process, but it will not terminate, and also that error will not propagate to other processes that is linked to it. For example, let's say I can do a small diagram here. In here we have the sender supervisor. Then let's say that this sender supervisor is linked to process A, process B, and process C. So we have a sender supervisor which is linked to other 3 processes. A, B, and C. So if something goes wrong with process C, if an error occurs in process C and causes it to crash, the sender message will acknowledge that exit message from process C, but it will not terminate. It will just continue running, and also that crash from process C will not propagate to process A and B. Now let's see if we can get the information of other processes that is linked to it. We can take advantage of the process where is again. It takes in the registered name, so I'm going to pass this. So this is the PID of the dynamic supervisor, and you can see it matches one of the process that is linked to the sender supervisor. Okay, so let's check now the process information of our dynamic supervisor. You can see the registered name matches what we have passed, and it's also linked to the sender supervisor. So this is the PID. It's only linked to one process, and that is the sender supervisor. This is the PID that we had initially, and also it's configured to a trap exit. Now we want to start our GenServer process dynamically. So to be able to start our GenServer process, we are going to use a function within the dynamic supervisor called the start child of RT2, takes in the supervisor and the child spec. So this function will dynamically add a child specification to supervisor and start that child. First, I want to define a helper function which is going to call the dynamic start child. Ideally, what I'm going to do is wrong. The reason why I'm saying is wrong is I would prefer, or I would recommend defining this helper function in a new file, but since it's one function that I'm adding, I'm just going to add it here in the server, but separate the client side with a comment from the server side. Let's define a helper function. The helper function, I'm going to name it as the start message server. When we were starting our GenServer process using the GenServer start function, it was taking two arguments. The first one was the message server module, and the second argument was a keyword list, which we were passing the max retries. But if we don't pass the max retries, it will default to 5. Similar to how our GenServer start function was working, it was expecting an argument. So I will pass here an argument which we will be able to pass the max retries to be expected by the GenServer process. So pass it as argument, but default it to an empty list if we don't want to pass anything. Then call the dynamic supervisor start child function. So this is going to take the name of the supervisor, which we have passed here. And also it's going to take the child specification. So the child specification here is the message server that we want to use to start our GenServer process. So I'm going to define the message server in here. And this message server will be taking arguments. So the argument here is the list that we're going to pass. To compile the changes, recompile the changes, then call the message server as start child. We have an error, and inside the error I can see the message server start link. So the error is not clear what the problem is, but when you call a dynamic supervisor start child function and pass it the child specification, it expects a start link function to be defined within the child specification. And here we have passed the message server, which needs to be started. So it was expecting the start link function from the message server to be able to start the GenServer process and link it. Let's define a start link because it's expecting a start link function to be defined. So this start link function also needs to take in an argument. So pass an argument there. So to be able to start the GenServer process, let's use the GenServer start link function. It will take in the module name. So you can pass it the module name that way, and also it will take in the arguments. So compile this and try again. If we do that, now we are not getting an error and we've been able to start our GenServer process. And also you can see that it's listening to the retry request. The other thing I want us to try is define this function in a different way. Call it start and see what will happen. After you change it, recompile, then start the message server. We are getting the initial error that we were receiving earlier. The dynamic supervisor start child was expecting the start link function to be defined within the message server. As long as you're calling the GenServer start link, you can define the function with any name that you wish to, but you should let the dynamic supervisor to know which function to invoke within the message server. We have the child specification options that are defined. So this child specification can be found within the supervisor documentation. We have the start option. The start option takes in a tuple with the module function argument to be invoked to start the child process. So we can add this start key within our dynamic supervisor. So let's do start. It's a tuple of the module, function, and argument. So this is the module, and now define the function. We have an error. Argument error. Supervisors expect each child to be one of the following: a module argument tuple, a child specification as a map with at least ID and start field, or a tuple with 6 elements generated by supervisor spec, but it is deprecated. Do I need to pass this as a map? A child specification as a map with at least ID under start. So let's pass let me pass it there as a map. They mentioned that the ID is a required field also. So let us try first and see. Invalid child specification. Let's try passing an ID and see. Let me see if this I'm not sure if this is the problem, but I need to find out where the problem is. I'm still getting the same error. I'm not really able to tell where the problem is. Let me just try to restart it. Okay. So I had mentioned that you can pass any function as a child spec when calling the dynamic start shell function. Well, this again. This is the PID of our GenServer process. Let's redefine this PID because we will need it when sending requests to our process. To define it, I'll use the PID kernel function. It was 0 to 19, 0. Now let's send requests to the GenServer process just to test if everything works as expected. So the GenServer cast takes in a PID, then we need to send the send message request. That is the send message. Pass it the number. So I'll start with the happy flow path. So we have sent a request to the GenServer process. The message has been sent to the given number and the job is completed with the status done. Also, after the job is completed, we terminate the process. So we have the process terminated, but now we have another behavior. So after the GenServer process is terminated, we can see that we have a process that is still listening to the retry request. That means we have another GenServer process that is alive, or the GenServer process has been restarted. This is the PID of the GenServer process that we started earlier when calling the start message server. What I want to check is which PID are we having right now. We have a function in the DynamicSupervisor which can help me know which children is started under that supervisor. I'm going to call which children function and pass it the name of our dynamic supervisor. So that name is message server. Two children are started within our dynamic, are started by the dynamic supervisor. And I'm not sure which PID, so this is not among them because this was already terminated. We don't expect it to be alive. We have two children started which are running This is interesting. So we can send requests to both of the PID. Let's try it. So the first one is the 205 and you have the 222. So let's call it PID1. I'm using the PID kernel function to get hold of the PID that we have seen inside within the children that has been started with our dynamic supervisor. Let's send requests to both. And also let's send requests to that and see the behavior which we're getting. So the first send message request has been received, and you can see sending message to 122, process termination with reason normal, then job is completed. Now I'm having another weird behavior, nothing happening. Let's see if this is alive. I'm expecting it not to be alive. And let's see if that is alive. They're both not alive, and I'm not sure what has happened. Let's say the process, which children are started. Now we don't have any children started by the dynamic supervisor. Okay, we can restart it again. Let's send a request to it. So just remember they need to define the PID. We can avoid this hassle of passing the PID each time and try to find the PID that has been started, because we have seen that whenever the job is completed, the dynamic supervisor is going to restart or to start another GenServer process. So to avoid this hassle, let's register our GenServer process similar to what we have done with the dynamic supervisor and the sender supervisor. Server start link. It also takes in the name option, and we can register it using the module name. This way, even if another GenServer process has been started, we don't have to keep on trying to find which PID to use. For the changes to be effective, restart the application. Let's start the GenServer process by calling the message server start message server. So we have started the GenServer process, and this is the PID of the GenServer process. But now we're just using this information to let us know that it has been started successfully. You can see that it's listening to the retry request. We can go ahead and send a send message request for it to send the message to the given number. I'll use the GenServer cast. GenServer cast takes in a PID or the registered name. Now that we know we have registered our GenServer process using the module name, it will take that, then the send message request. I'll start with a happy flow again and see. So send message to, so the message has been sent, the job has been completed, and we have another GenServer process started. Now what happens if we introduce an error within the GenServer process? Let's use the same number that returns a message which is not handled within the message server. We're going to expect the GenServer process to raise an error and to terminate. You can see we have our GenServer process. Our GenServer process has been terminated, and also we have another GenServer process which has been started by the DynamicSupervisor. Unlike the behavior we got using the GenServer start or the GenServer start link function, whenever the process terminated with the GenServer start, we had the GenServer process being shut down and we had to call the GenServer start function again. But in this case, the supervisor is handling by restarting the GenServer process. Also, we can try to see which process are linked to the DynamicSupervisor. Let's get the PID of the DynamicSupervisor. We have to use the where is. So this is called the message server .DynamicSupervisor. We have the PID of our DynamicSupervisor. We can now check its information by calling process info and pass it to the PID. So it's linked to two processes. So let's confirm both where they are coming from. Remember the DynamicSupervisor is supposed to be linked to the sender supervisor and also to be linked to our GenServer process. To confirm that, we can check process where is for the sender supervisor. So we have the 0.189.0. So one of them is the sender supervisor. Also, we can use the dynamic which child to know which children has been started by the DynamicSupervisor. And you can see we have the worker here referring to the message server, and this PID matches what we had in the information that we checked for the DynamicSupervisor. That's it for this episode. We have been able to use the DynamicSupervisor to dynamically start our GenServer process. So this GenServer process is going to be added as a child specification under the supervisor. And in case anything happens within the GenServer process, the supervisor is able to restart it.